Welcome to my experimental study and thanks for participating today. My name is Christina Adam and I'll be showing you a brief tutorial video about two data modeling approaches that will be subject in today's experiment. First of all, what is a database? A database is an organized collection of data ideal for storing as well as retrieving information. So basically a bunch of tables that hold your information, but they're linked so you don't get a lot of duplicate data. This makes it easier to find your information later because you can make a search instead of seeing the data all at once. The first step in creating a database is to create a data model. A data model provides appropriate structures of data that address and support the business requirements. So you might want to ask yourself, what are the things that need to go in a database and what information you want to keep about those things. There are two kinds of data models that we want to look at today. The diagrammatic entity relationship diagram, short ERD, and the text-based, fact-based information modeling language, short FIML. Let's have a look at the ERD first. The main concepts of an ERD are entities, attributes, and relationships. Entities are displayed as a rectangle that contain attributes and can participate in relationships with other entities. So entities may be representing a person, place, thing, or event that you want to track in a database. For instance, an employee. The entity employee is a representation of all employees in the real world. Now we want to define the employee a bit more, and therefore we need attributes, which are basically pieces of information about the employee that we want to know. So here we might want to know the employee's first name, last name, date of birth, start date, and position within the firm. A particular instance of the entity employee could be Michael Adams with his date of birth, start date, and business analyst as his position within the firm. Next, we want to make sure that we can uniquely identify each of the employees. However, none of the attributes we've defined so far can ensure a unique identity, as there could be two employees with the same names, for example. And hence we need another attribute that uniquely identifies the entity, such as an ID or a code that is only used once. In an ERD, a unique identifier is an attribute that is underlined, in our case, an employee ID. Now, to connect information with each other and be able to navigate around in a database, entities participate in relationships. A simple example is the one we've got here with employee and department, where we can say an employee works in department and department has employees. So clearly there's some sort of relationship between those two. But we also need to specify the type of relationship by saying how many instances are allowed or necessary between those entities. We've got four different options, and here we talk about cardinalities. The first one is one mandatory, saying must be one, which we draw by two single lines, the first one for mandatory, saying must, and the second one for one. The next one is many mandatory, saying must be one or many, which we draw again by a straight line for mandatory or must, and a little crowfoot for many. The next one is one optional, saying it may be one, and may implies it can be zero. So we draw that by a little circle, which is may or zero, and a straight line for one. And many optional, saying may be one or many, and again, may means it can also be zero, which we draw by, again, a little circle for zero, and a little crowfoot for many. If we now go back to our relationship example, the relationship between employee and department could look like this. So employee must work in one department, and department must have one or many employees. So it is a mandatory many to mandatory one relationship. There's also a particular way of how we verbalize the relationship, and that we do in a clockwise manner, and we also identify descriptive labels that match how we would read from employee to department and from department to employee. So in our case, that would look like the following. Employee must work in one department, and department must have one or many employees. We could have also identified the relationship on the employee side as optional many, and then we would say department may have one or many employees, implying could also be zero, but that would imply that a department can exist with no employees assigned to it. And just because I thought it's not very realistic to have a department without at least a head of department assigned to it, we just leave it as a mandatory many relationship. To now complete the relationship and allow navigation through the entity structure, we also take the unique identifier of the one side of the relationship, which in our case is department ID, and copy it into the entity with the many side of the relationship, which is employee. And that step creates the actual linkage between two entities, and now we are able to move between those entities via this particular attribute. And to make sure that we know that department ID is the unique identifier of department and not of employee, instead of underlining it, we write it in italics. So now every time we need information from different entities, we can move around entities and move in between entities where we've got or need information from via the unique identifiers, as they create the linkage from entity to entity. We can also come across cases where we want to identify an entity by a compound identifier, which means that the identifier consists of more than just one attribute. For example, in our case here, we have employee who's assigned to an assignment, and the assignment describes a project. Instead of identifying a new assignment ID, we can just copy the unique identifiers of both employee and project. And again, remember that these are on the one side of the relationship, and copy them into assignment, which, just as we've done before, creates the actual linkage. And that's why we write both employee ID and project ID in italics. But because those two combined together can also ensure the unique identity of an assignment, we can just make it a compound unique identifier of assignment, and that's why we also underline it. The last concept is about subtypes. Subtypes apply when we have an entity that can appear in different forms and hence require some different information. So for instance, an employee can be an employee on an hourly rate or on a contract. While both have the same attributes that are defined in employee, which are employee ID, first name, last name, date of birth, start date and position, they each have some additional information. For an employee on an hourly basis, you may want to store information about the hours agreed on and the hourly rate. And for a contract-based employee, you maybe want to save information about the contract itself and the salary. In an ERD, subtypes are displayed in the following way. And each subtype, as we just said before, inherits all the attributes defined in its so-called superclass, which is employee. That means, just for example, that an hourly employee doesn't only possess the attributes hours and hourly rate, but also the 6 attributes defined in its supertype employee, including the unique identifier. So here we can see a complete model of the concepts that we've just talked about. Departments which must have employees. Employees can be either hourly employee or a contract employee, where each employee may be assigned to an assignment, which in terms must describe one project. Just take a few seconds and go through the model again. Something I want to add to the model is a data dictionary, which is quite common. And this gives plain business definitions about the entities and the attributes that are contained in the model. And that ensures that you'll get a bit of a better idea of what they mean within the model. So for example, assignment is a task allocated to someone within a project. For attributes, we also store value types, and that basically tell you in what value an attribute can be stored in. So for example, in a number, a text, a date, or a dollar value as the most common ones. So we've now covered the basic concepts of an entity relationship diagram. And now I want to go on to the next modeling approach, which is called Fact-Based Information Modeling Language, short FIML, which is essentially different from ERD. So instead of using a diagram, FIML uses only natural text to describe the model. And the other main difference of FIML is that it doesn't use the concept of attributes, but quite different structures and concepts instead, which we'll look at now. The main concepts of FIML include objects, which are things of interest, and that can be values or entities, roles that are a part an object plays in effect, then facts, which are the relationships of or between objects, quantifiers, which are the cardinalities in relationships, and subtypes, which is the concept of inheritance. Starting with objects. So an object is an individual thing of interest. An object can occur in two different ways. As a value, which is a thing that we can write down and store, for example, a name or a number, such as Michael Adams or 12345, or as an entity, which describes a thing that can be identified, but not necessarily be written down or stored as such a person or an employee Adams. And that's why we have the value types. So we can identify each entity that we can't write down to have a value by which we can write it down. So going from the real world to the FIML language, the language uses object types to provide a definition of the characteristics of a set of similar objects, which each instance can make use of. So for values, we said that we can write it down, and FIML now defines how it is written down. So for example, each name is written as a string, each ID is written as an integer. And string and integer are data types that we don't emphasize on as they won't be relevant in the experiment. For entity, we said there's something that can be identified, and now we want to know or define by what and how they are identified. So we can say each employee is identified by employee ID, or make a shortcut and say each employee is identified by its ID, and FIML automatically creates an employee ID that is uniquely assigned to an employee. The next concept of FIML are role names, which enable the same object type to occur multiple times in a fact type, but in different roles. So it's basically a part played by an object type. There are three different roles. The first one is the direct role, which is just the object type itself, such as employee. The next one is the qualified role, which is a part of or a further distinction of a role by specifying adjectives to the object, such as first name. And the last one is the explicit role, and that's where we provide a distinctly different name for a role. And remember, because a person we can't write down, we need something to identify it with to write down a value of this entity. So here we can say name as CEO. Now we want to look at the concept of facts, which are relationships between roles or characteristics of a role. We distinguish between the number of objects and the role they play that are included. So, one role included, employee Adams smokes. Two roles included, employee Adams works in department IT. And more than two roles, employee Adams works in department IT on project test. So all these three readings are meaningful sentences relating the roles of a fact type in close to natural language. A reading is often constructed from a verb between the first two roles, and a preposition between the following roles, if applicable. So in our case, in the third one. And something I want to add here is that facts between two or more objects can have multiple readings representing the different ways the same information can be expressed in natural language. So instead of saying employee Adams works in department IT on project test, we could also say project test is executed in department IT by employee Adams. FIML now defines fact types to provide definitions of relation patterns between one or more roles. And again, we have readings with different numbers of roles included. And as you can see, the FIML text is just in the real world examples, only without the actual instances. So employee smokes, employee works in department, employee works in department on project. We also have a bit of a special case where we want to name a fact type, and one example is employees assigned to project. Here we can only store information about object types, so employee and project. But what if we want to store information about the relationship? So what we have to do is name the fact type. So the fact type here is assigned to. And we make this an object type assignment, so we can now use this as an object type and store further information about it, such as the date or the hours. The way that FIML presents named fact types is by is where. So it says assignment is where employee is assigned to project. But when you remember back what we said at the ERD, that there's always verbalizations both ways. We have the same in FIML, and they're called two-way readings. So what we want to add here is not just saying employee is assigned to project, but vice versa, project engages employee. Similar to an ERD, we can identify quantifiers, which define the number of objects participating in a fact type. And in fact types, the quantifier is always written before the last row of the reading, which we'll see in a second. So the quantifiers are 1, employee works for one department, at least one, department has at least one employee, at most one, which means 0, 1, and an example is employee has at most one position, and many, employee is assigned to project. So as you can see, we don't actually write down many in the example. So we don't say employee is assigned to many projects. This is because many is implied. So whenever you have a reading and you don't see any of the other quantifiers, you can know that it is many. And many means anything from 0 to many. If you now want to look at an example, and we look at the ERD on the right-hand side, and that was where we had employee must work for one department, and a department must have one or many employees. What we do in a FIML is first we identify the entities. We then create a relationship, so the fact types, employee works for one department, department has at least one employee. And we then define the roles of employee and department. And in ERD, those would be the attributes. The last concept I want to talk about is subtyping. And subtyping is the concept of inheriting all the characteristics of a supertype to its subtype. And that we write as is a kind of in FIML. So we can say contract employee is a kind of employee and hourly employee is a kind of employee. And that's what it was, or how it looks in ERD, as we've seen before. So having covered the main concepts of FIML, this slide now shows the complete model of our example used within the tutorial. We identify the value types, then the entity types, where each of them is identified by its ID, and again its ID implies that it actually creates employee ID, department ID, and project ID. Then we've got two subtypes of employee that are described before going into the fact types, so the relationships between employee and department. And then we've got our named fact type assignment and all the roles that the objects play. And here we've got employee, department, contract employee, hourly employee, and assignment. Please take a moment to familiarize yourself with the model. Okay, so we've now covered the concepts of the two data modeling approaches. And before going into the experiment, I want to give you a brief guidance so you know what you expected to do. So throughout the experiment, you are provided with a set of demographic questions, survey questions, which are a total of 44 questions to 4 models, and some self-estimation questions about the models at the end of the experiment. The 4 models will be 2 ERD models, 2 FIML models, both in a simplified and more complex version. When you go through the experiment, please read the questions and instructions very carefully. When you're provided a link to the models, make sure you have 2 windows open side by side, so one with the model and one with the survey questions. So that makes it easier to look at the question and simultaneously go through the model and look for the answer. It is very important that you take your time to answer each question properly. However, please try not to pause or go away from the screen, as the time will be tracked you take to answer each model. In case you do get interrupted, note down at which question you stopped, for example, question 5, model 3, together with the length of your interruption. At the end of the survey, you will be provided a comment field to note down this information. You can also leave your email at the end of the survey if you want to be notified about the results of the experiment. And please note here, you will stay anonymous. So I just want to give you a brief run through the models and how they are presented to you so you know how to find your way around. When you click on the model of FIML, you get redirected to another browser video and a browser window, and the model is embedded into this tool here. You have the editor, the glossary, and the output. You will only be focusing on editor and glossary, and the editor is basically just the plain model. You will find it probably very helpful to work with the glossary, because the glossary summarizes all of the concepts on one side. So you've got all the concepts in a little search bar on the left, and you can just click on any of the object types or value types or whatever you're looking for. For example, product, you have a plain definition of product here, so it's basically the data dictionary of FIML, how it is identified, and then the usage wherever product appears throughout the whole model. And you also note when you go over the object types, you can also click on them. So you can click on vintage here, for example, and you get redirected to all the concepts of vintage. Okay, that's probably as much as I want to say about FIML. When you're presented with ERD models, you simply have a PDF with a little bookmark selection on the left, and you've got the model. There's nothing to click on, and below you've got the data dictionary with the business definitions about the concepts, and that's in 2 parts, so entities with the definitions and the attributes with the definitions. Okay, so that's about all the information you will need. Thank you again for listening to the video and for participating in my experiment.